Good morning. My name is Michael Jones. I'll start by asking all of our non-speakers to please turn off your cameras and also be on mute. Thank you very much. So this is part of a series of monthly webinars. This one is BlueTech Space and the Circular Economy. Thank you for joining us. As of this morning, we had 108 registered. My guess is we'll have a few more. If we could move on, please. You can see here at the top, in March, we did water, wastewater in the circular economy. Today is BlueTech Space in the circular economy. Next month, and we're doing this in conjunction with NASA JPL. Next month, we have a partnership with the National Oceanography Center in the UK. So we'll be doing ocean sensors in the circular economy. And then in June, seaweed in the circular economy, which shows you that we have a theme this year, which is the circular economy. Our purpose is to bring together people that often don't meet across countries. Our companies have different needs. Sometimes those needs are investors, sometimes they're management, sometimes they're channel partners. And so this is a forum to get people together so that they can find ways to create value together. Our presenters are always innovative SMEs. So we're talking about companies, not for profits. And our goal really is to focus on innovation in ocean and water wastewater. Broad audience, as I've said, agenda is always the same. We start right at 7:45. I take about 5 minutes when we have a featured speaker who is today Séverine Fournier, a scientist with Jet Propulsion Laboratory. Normally we have 3 companies presenting. Today we have 4. We found so many interesting companies we couldn't even. There are several more that we would have liked to included. Normally we have 3, taking 10 minutes each, and at the end we have 30 minutes of Q&A. What we would like to do today is extend 10 minutes, so we still have the Q&A, but each of our companies will speak for 10 minutes. Next, please. So this is just to show that our partner, Formoseano, in the national cluster of Portugal, we have launched TMA Europe. We're thrilled, of course, to be working with them. We have several other relationships with them, but our goal is to also find a soft landing spot in Portugal for those that are interested in setting up in the EU and particularly in Southern Europe. Next, please. As I mentioned before, we also have signed an MOU with the National Oceanography Center, and in the lower left, please join us on May 20 for our event that we will be doing with them, which is Ocean Sensors in the Circular Economy. Every month we have typically 3 companies, this month 4, from different countries. And this month, as an example, we have from Israel, from Portugal, from although it's France and the UK, and then from the United States, always one of our member companies. Next, please. Just a reminder, April 22nd is Earth Day, and I think that this event underlines how important the ocean economy is the space economy is for the sustainable blue economy. Next, please. I've just discovered that I have a very leaky pen that has decided to leak all over my hands. Our 13th annual Blue Tech Week will be in November. It's always in the fall, and we also will be working with our Formoseano partner. That same week, they have their annual Business to Sea conference. We will be working together in terms of companies that want exposure both in the United States and in Europe. Last year, we were virtual, as we will be again this year. We had 665 attendees and speakers from 37 countries. Great topics, great speakers, great contacts, and hopefully you'll put in your agenda to join us. Our theme for Blue Tech Week is Aqua Optimism, Inclusion, Inspiration, and Innovation. Next, please. Our team, small but powerful. We are looking for an executive director. If you have any great candidates, please send them my way. Tamara is our program manager and really made these happen. Vanessa Tang is an intern that we have at this point. Next, please. Just some legalese. We hope that there may be some investors in the audience, and if they do invest in any of these companies, we're thrilled, but we're not giving investment advice. Next, please. By registering for this event, you gave us rights to send you information. You can always take yourself off our constant contact. Next, please. Please, please, please set your computer audio to mute and turn off your camera. When you put your camera on, we see you walking around and we hear things, and it's just very disconcerting for the speakers. The way you can ask questions is when everybody's speaking, use the chat function, please. And that way your questions will go to Séverine, and then she will be asking the questions for all of us. Next, please. So without any further ado, we have been on monthly calls with the chief scientist of NASA, Dr. Jim Green, and one of his associates, Dr. Catherine Walker. And as we were talking about the interaction between Earth science, Earth observation, and the BlueTech, they identified a couple of people from JPL, and so we have gotten to know Dr. Séverine Fournier, who agreed to give us some introductory words, and then she will come back to moderate the Q&A. So, Séverine, thank you very much for joining us, Jorge as well, and the floor is yours. You've got 7 minutes.
Okay. So, wait a minute. Okay. So I'm Séverine Fournier. I'm a research scientist at NASA. So I'm going to talk about how NASA satellites contribute to understanding how freshwater moves on our planet. So the water cycle represents the exchanges between the atmosphere, land, ocean, and the cryosphere. Most of the water is stored in the ocean, and most of the exchanges happen between the ocean and the atmosphere. So the oceans really play an important role in the water cycle. And the water cycle is expected to intensify in a warming climate with more extreme droughts, floods, and stronger storms. And because water is fundamental to all life, this climate issue will have a significant impact on society. So although runoff only account for 10% of the total freshwater input to the ocean, the land-ocean interface is very critical to the coastal ocean. So rivers discharge a huge amount of sediments that have an impact on the carbon cycle, ecology, erosion, and they also discharge a huge amount of freshwater that have an impact on the Earth's interactions, as convection, rainfall, hurricane intensification, etc. So the coastal ocean and the land-ocean interface are very important because 40% of the world's population lives within 100 kilometers of the coast, and they're impacted by storms, inundation, erosion, fisheries, sea level, and water availability, etc. And also there are different ecosystems that are living in the coastal ocean, and they're impacted by changes in their environment. So NASA has a bunch of satellites that observe the Earth, and especially the water cycle and the coastal ocean. So here are a bunch of different measurements, and I'm going to focus on sea surface salinity measured from space. So NASA has a satellite, SMAP, that measures ocean salinity and soil moisture on land. So this is an animation of SMAP data. So on land, blue means wet, like the Amazon basin, and orange means dry, like the Sahara Desert, for example. And in the ocean, red means salty, and blue means fresh. So we can see the water's discharge, the freshwater discharge by the Amazon River that are captured by satellites, and they're not mixing right away, and they can be traced like thousands of kilometers from the mouth of the river. So I'm going to talk about different studies. So for example, SMAP was really able to capture the whole life cycle of a flooding event in Texas in May 2015. So we have, at the end of May, saturated soils due to all the precipitation. And all these waters ended up in the ocean at some point from several weeks to several months. So these waters were carried along the shelf of Texas and then ended up in the central Gulf of Mexico. And that was the first time that I was captured by satellites. So it was really an unusual presence of freshwater in the central Gulf of Mexico. So it's very important to monitor these kind of unusual events because the Gulf of Mexico is the second largest dead zone in the world. It's an area where there is not enough oxygen to support living organisms, and the extent of a dead zone depends, among other, on the river discharge. And there are also different ecosystems like a coral reef on the Texas shelf. And with repeated flooding events since 2015, these coral reefs have been reporting dying. And if you change their environment, like temperature, salinity, and light availability, that can damage this ecosystem. So we've been talking about surface runoff, but there are also submarine groundwater discharge, with this water flowing from the land to the ocean below the surface. And they play an important role in the marine ecosystems because these cold waters are a refuge for ecosystems that are sensitive to heat. And they're also a source of nutrients and alkalinity, and they can also be a source of fresh water. So high-resolution space sensors have been able to detect these submarine groundwater discharge by measuring temperature anomalies. On the upper graph, you can see these red dots. These are the SGDs that are detected. Salinity sensors could be very helpful here by detecting the fresh water, but they're very limited by their resolution and distance to the coast. So finally, I'm going to talk about hurricane intensification on the shelf. So in 2018, we had the Hurricane Michael that came on the Gulf of Mexico and intensified to Category 5 right before landfall, a day prior. And that was not predicted by models, and people didn't have time to prepare. So we really wanted to understand what happened. Space sensors like sea surface temperature data gave us an idea that there was a marine heat wave just before landfall, and we need to understand the mechanisms behind the marine heat wave. So in situ data were really helpful by giving us information on the stratification and heat content, with like the waters were mixed a month prior, bringing the warm water to the bottom of the ocean, and then atmospheric heat wave warmed the surface. So we had an extreme heat content, and hurricanes are fueled by heat content. So in situ measurements were really helpful here, and salinity and altimetry sensors from space could be very helpful, but they're limited by their resolution and distance from the coast. So coming up is a SWOT to be launched in 2022, and SWOT will give us estimates of river discharge levels. And until now we have gauges, but not all rivers are gauged, and they're very expensive to maintain. And also some countries don't want to release their data for political reasons. So SWOT is going to be very helpful here. And it's also going to provide us with a high resolution coastal sea surface height and currents. So we're going to be able to understand where the water goes from the land to the coastal ocean, and going to give us an information also on the heat content on the coast. This is really important for interactions with the atmosphere. So to go further, we need more in situ measurements on the shelf, and especially in regions that are undersampled. So the Gulf of Mexico is pretty well sampled, but it's not the case of all the regions in the world, especially on the shelf. And also, ideally, we would need high resolution measurements of sea surface salinity near the coast that can be very helpful to study coastal processes. So thank you very much. And here I give links to NASA Ocean Data and NASA visualization tools.
Severine, thank you very much.